Lake Erie Screw Corporation is a manufacturer of high-quality cap screws. We'd like to show you how hex head cap screws are made. Our products, made from domestic steel, are traceable from the finished product back to the original steel heat number. Traceability begins at the steel mill. Prior to being shipped, the chemistry of every heat of steel is checked, and a mill tag is attached to every coil indicating chemistry and heat number. We receive the raw material in a hot-rolled, non-annealed condition. Pickling cleans the coils by suspending them in a solution of sulfuric acid and water. To remove as much acid as possible, coils are rinsed with water. They then receive a heavy lime coating. The lime neutralizes any remaining acid and protects the raw material should it not be used immediately. It also acts as a vehicle to pick up a dry lubricating compound used later in the bolt-making process. Every coil is marked with a color-coded stripe to indicate its steel chemistry. A second tag, which identifies size, chemistry, and heat number, is placed on each coil. Annealing is a form of heat treatment that softens the steel, alters the metallurgical structure, and increases ductility and formability. An annealing furnace has 4 main parts. The base is surrounded by a water-cooled, hard rubber gasket which forms a seal. Once in place, the inner cover contains a controlled atmosphere. This atmosphere ensures that raw material is not carburized or decarburized. The material is softened in a carefully controlled heating, soaking, and cooling process. A typical annealing cycle is from 24 to 48 hours. The raw material is now ready for the bolt maker. First, it passes through an auxiliary wire drawer to size and straighten it, improve the surface condition, and apply a lubricant. By passing a carbide die over the raw material, the material diameter is reduced by approximately 30 thousandths of an inch, providing an accurate and consistent raw material size for the bolt maker. At the same time, a lubricating powder is pulled through the draw die opening and forced onto the wire. This combination of lime and dry lubricating powder provides the only lubrication between the raw material and the inside diameters of the carbide forming dies. The bolt maker used to manufacture cap screws is a horizontal, multi-station mechanical press. Let's follow the progression of a blank as it's mechanically transferred through the forming stations. Wire is fed into the machine and a blank is cut off the main coil. Blank length depends on the desired length of the finished bolt and the size of the head to be formed. The blank moves into the first forming station. The ram moves forward, forming an upset, which is a deformation of stock put on one end of the blank in preparation for forming the head. The blank is then kicked out of the die and carried to the second station. There, the ram forges the button. The body size of the bolt is developed. The washer face, underhead radius, crown on top of the head, and head marking are put on. Next, the bolt is pushed into an extruding die. The body diameter is reduced to the pitch diameter of the final thread form. The bolt is then transferred to the trim station. A square or hexagonal trim die moves forward to shear excess metal from the forged button, forming a hex or square shape. A water-soluble oil keeps the bolt and trimming die cool. It also keeps chips and dirt from gathering inside the trimming tool. As the bolts pass through the trim die, they form a column in the transfer tube. This tube allows for the transfer of bolts from the die bed to the auxiliary pointing station after the trimming operation is completed. When the bolts reach the top of the arc of the tube, they gravity feed downward to the pointing station. In the pointing station, a set of grips hold the bolt stationary as it's cam-fed into a rotating carbide cutting tool assembly, forming the chamfer. A mechanical conveyor carries the pointed bolts to the roll thread section. Two flat roll thread forming dies, one stationary, the other movable, form, not cut the thread. As the bolt is fed into the dies, the moving die carries it forward, rotating the bolt approximately 3.5 turns, penetrating the pitch diameter. Material is displaced outward into the thread crests, generating the final thread form. This provides a strong, smooth thread form of consistent dimension and quality. You've just seen how a bolt is formed. A blank is cut. An upset or preform is put on. The head is formed along with the washer face, radius under the head, and head marking. The bolt is reduced in diameter from body size to pitch diameter. The finished head shape is trimmed. The bolt is chamfered on the bottom end, and finally, the thread is rolled. When all the stations of the machine have been loaded, every stroke of the machine produces a complete bolt. If a hex head cap screw were made from hexagonal material in a screw machine, up to 80% of the raw material would become scrap. The cold heading process produces as little as 10% manufacturing scrap. We believe that quality must be built into each and every cap screw we produce. It cannot be inspected in at the end of the process. All orders manufactured at Lake Erie Screw are produced by using an in-process inspection system that maintains traceability from the raw material through all operations to the finished product. Our in-process inspection system forms the framework for our statistical process control system, which is also used on all orders produced at Lake Erie. A production lot number assigned to the SPC record allows the identification, tracing, and retrieval of these records from our packing lot number. Once formed, bolts must be hardened and tempered through heat treatment to create the desired strength level. Like annealing, hardening is done in a controlled atmosphere to prevent carburization or decarburization. Bolts fed onto a furnace belt are soaked in the furnace for approximately 45 minutes. During the hardening operation, the elements in the steel's chemistry experience a significant change by going into solution, providing a uniform structure throughout the cap screw cross-section. When this structure has been achieved, the bolts drop through a chute into the appropriate quenching solution. After quenching, the bolts are washed, placed in a hamper, and loaded into the tempering furnace. In tempering, the bolts achieve the required strength level and the ductility of the finished product is increased. Each furnace has its own area for monitoring and recording the quality of every order heat treated at Lake Erie. At regular intervals, the operator checks hardness on one of the as-quenched samples. Hardness of tempered fasteners is checked on every load. A bolt is selected from the top, middle, and bottom of the hamper to ensure that a uniform hardness has been achieved throughout the load. Each furnace has a numbered record for every shift. Operators enter customer's name, order number, type of steel, heat number, hardness requirement, and other data on the record. At the end of the shift, product samples are sent to the lab for testing. Results are added to the record, and from this information, we develop a permanent lot number for each order of bolts. This lot number permits traceability for all Lake Erie finished products. Our fully equipped lab can do any testing required by commercial bolt manufacturing specifications. All samples are tested full size according to the ASTM F606 testing specification, which requires the use of a wedge under the head during tensile testing. Specifications demand that the tensile failure occurs in the thread or shoulder section of the fastener. If any irregularity is observed during testing, the order is immediately put on hold, the cause of concern investigated, and a disposition provided. In addition to proof load testing, Rockwell C, Brinell, superficial, and Tucon tests are conducted. Our metallurgical staff examines the microstructures of at least 2 samples per furnace per shift. Our gauge laboratory includes micrometers, optical comparator, thread ring gauges, master ring gauge set plugs, super micrometer, computerized measuring systems, and Skidmore-Wilhelm load tester. MagnaFlux, a visual non-destructive test, detects seams and other linear discontinuities on finished fasteners. A magnetized bolt is sprayed with a solution containing a very fine particulate matter. In an inspection tent, the bolt is examined under a near ultraviolet black light. Any particles drawn into the discontinuity will be visible as a very vivid yellow line. Lake Erie maintains a large inventory of grade 5 and grade 8 cap screws, structural bolts, and various classes of metric cap screws. We can manufacture special fasteners and provide secondary operations such as grinding, drilling, applying locking elements, and various types of plating. We are a company that reacts to meet new challenges, as evidenced by our involvement in SPC, just-in-time delivery programs, paperless ordering systems, special packing requirements, and barcode labeling. Our goal at Lake Erie has always been to provide a quality product that invites comparison with the best. You've seen what we can do and how we do it. We're a dynamic, growing organization. We believe in American manufacturing and are proud to be a part of it.